Hello everyone, welcome to the YouTube channel Nerd Academy. In this lesson series, we will learn about the logic gates, its details, in types in details. Okay. So briefly, logic gates are digital circuits. They are very basic building blocks of any digital system. Simply, we can say it is an electronic circuit having one or more inputs and only one output. Now the inputs and outputs of these logic gates can have only two values. The logic 1 or high value, the logic low or the 0 value. Okay, these values represent the value level of the circuit system. So we can categorize the logic circuit in three types. They are basic logic gates, universal logic gates and special logic gates. In basic types, gates are AND gate, OR gate and NOT gate. Universal logic gates are NAND gate and the NOR gate. Special logic gates can be referred as XOR gates and XNOR gates. Today we only focus about the basic logic gates. They are AND gate, OR gate and the NOT gate. So let us with the AND gate. This is a symbol of the two inputs AND gate where the A and B are the input of this AND gate while the Z is the output. AND gate represents the multiplication operation. You can see this. So the output is equal to product of all the input. So here output is equal to A dot B. Okay, A dot B, the product of A and B. Let's understand with the help of the truth table. So the truth table shows the all possible combination of input signals and the corresponding output for those input combination. 0.00, 0.10, 1.0 is equal to also 0, 1.1 is equal to 1, that means high value. From this truth table, we can clearly explain the operations if one of the input is low, the output also is equal to 0. That means low value. When the both inputs are high, then only we can get the high as output. So here is the symbol of the three input AND gate, where there is the A, B, C are the inputs of this AND gate, and if C, Boolean expression of these three inputs AND gate, then the output is equal to A dot B dot C. Okay, that means all the three inputs are high, then the output of AND gate will be equal to high. Otherwise, all the outputs are equal to low, that means 0. You can clearly see if any of the inputs value is equal to 0, you can see it. Likewise, we get 0 as our output value. So now let's us move on the next gate. This is a OR gate. This is a symbol of the OR gate. A and B are the inputs of this gate and Z is represent the output. OR gate represent the addition addition operation. So the output is equal to sum of all the inputs. So here output is equal to A plus B, the sum of the A and B. The truth table for this OR gate given like this: inputs A and B, output is equal to Y is equal to A plus B. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, 1 plus 1 is equal to 1. So from this truth table, the operation can be explained like this. Here we can clearly see one of the input is high. One of the input is high, then the output also equal to high. Output always equal to high. When the both inputs are equal to 0, then only we can get 0 as our output. You can see this, clearly see this. Okay. Similarly, we can also have an OR gate with more than 2 inputs. So here this symbol is of the 3 inputs OR gate, and if we see the Boolean expression of this OR gate is equal to A plus B plus C. A plus B plus C. That means if all the 3 inputs are low, all the 3 inputs are is equal to 3, then only output of OR gate will be equal to low. Output equal to low. And in any other cases, the output of the OR gate will be equal to high. You can clearly see. These all outputs are equal to 1 because the one of the input is equal to 1. So similarly, the next gate is a NOT gate. Our last basic gate is a NOT gate. That is also called as an inverter gate, because in this gate the output is the complement of, you can see this, complement of the input signal. Complement of input signal. Here we can see only one input and one output signal. As I mentioned before, output is complement of the input logic. Z is equal to not A. That means complement of A. Okay. If here truth table given show the combinations of outcomes and inputs. So if input is equal to 0, that means low, then the output will be equal to high. Likewise, if the input is equal to high, then the output will be equal to low. The symbol of the NOT gate is this. Here we can see a bubble. Bubble represents the inverting operation. This symbol we can see our future lesson also. So again I mentioned this. If A is an input, we can get the output as A bar. The complement of A, complement of A, not A. We also call as a not A. This AND, OR and NOT gates are the 3 basic gates using which is possible to design any logic circuits, or it is possible to implement any Boolean functions. So this is a summary tables of our lesson series, but only I discuss here AND gate, OR gate and the NOT gate. Please refer these informations. So hope you have enjoyed the lesson. Let's meet with the next part of Logic Gates lesson series. Thank you so much. Stay tuned.